Hi, welcome. So in this video, we're going to start talking more about transformations of sine and cosine. And specifically, we're going to look at starting with the formula and then creating the graph from that. So in another video, we'll go from the graph to a formula, but we're going to focus on formula to graph in this video. So first, I just want to summarize quick the types of transformations we have. So I'm going to combine the sine and cosine together. So I could say we have A times either sine or cosine of B times theta plus or minus C, and then that is all plus or minus D. So these are all of the possible transformations that we could have. Typically, we only have one or two, maybe three. It's very unlikely to see all four at the same time. That's just a lot to keep track of, but of course it's possible. So the transformation A tells us the amplitude, so the amplitude is that A value. Then B adjusts the period, so the period becomes 2 pi over B. Then plus or minus C indicates a phase shift, right or left by C. And then the midline is the D value, so the midline shifts to either be positive or negative D. So we'll see how these things play out now with some examples, but this is just a summary of what we talked about in the last video. All right, so for our first example, we're going to do quite a few things. So first, we're going to identify the transformations that are present. I'll show you the formula that we're going to look at in a second. Then we're going to find the period, midline, and amplitude. And we're also going to sketch a graph of the function. Let's say we have f of theta equals 2 sine theta plus 3. So first, let's identify the transformations. I see we have a 2 multiplied by that sine, and so that's an A transformation, so it's a vertical scaling by a factor of 2. So 2 is a vertical scaling by a factor of 2, and then that plus 3 is on the outside, so this is a shift up by 3. So we have an A and a D transformation. Then let's identify the period, midline, and amplitude. So our period is affected by the B transformation, but I don't see one of those here. So my period is just going to be 2 pi. That means it's unchanged. It's just what the original sine function's period is. Then our midline is affected by the plus or minus D transformation, and I see that here we're shifting up 3, so that's going to shift the midline to y equals 3. Then our A transformation affects the amplitude, and so our amplitude is now 2. All right, now that we have our transformations written out and we know how they affect the period, midline, and amplitude, let's try to sketch these graphs. I just want to say that when you're graphing sine and cosine for the first time, it can be kind of hard. It's kind of a new way to graph, and honestly, even when I do it, I often mess up and have to erase. It's just difficult to draw the curves well, especially since it has such good symmetry. It's hard to get it looking nice. But just do your best and give yourself some patience as you're doing this for the first time. Okay, so I'm going to give us some axes here, and I'm going to remind us of the period, midline, and amplitude, and the function that we were given. So to start, I'm just going to graph the original sine function. So I always remember that sine has a point at 0, 0, and then it goes kind of positive to the right and negative to the left. When I'm doing these problems, especially for the first time, I like to have a reference sine and cosine graph near me just to really remember what they look like. So that might be helpful to you as you're working through this, to just have a little graph of sine and cosine somewhere. Okay, so this is sine, and we're going to transform this. I like to do one transformation at a time rather than try to jump all the way to the end, but as you get more practice, you might be able to do that. So the first thing we're going to do is move that midline, so the midline becomes y equals 3. You could do them in the other order, I'm just going to do it this way. So I'm taking this whole graph and I'm shifting it up to y equals 3. So this is now sine of theta plus 3. Then this graph currently has an amplitude of 1, but I want to make an amplitude of 2. So I need to stretch these points to have a height of 2. I like to take the maximum and minimum values and just think about kind of pulling them up to where I need them to be. So I need them to be up 2 instead of just up 1, and so I'm going to plot those points and just connect the dots. And there we go. This is our 2 sine of theta plus 3 graph, and our final answer. Then we can just check and make sure we did it right. So I see that the period here is still 2 pi. I can pick points that have the same outputs, so maybe 0, 3, and 2 pi 3. This is 2 pi that it takes to start repeating itself, so my period is 2 pi. Then my midline is at y equals 3, as I wanted. and my amplitude is 2. So I see that the height from the midline up to the top or bottom is 2. Okay, let's try this on another example. So let's say we have g of theta equals cosine of 2 theta minus 5. So I'm seeing we have two transformations here. We have something with the 2 and something with the 5. And let's start with the 2. So it's being multiplied by the theta, so this is happening to the input of the function, meaning it's a horizontal transformation. Specifically, it's a B transformation, so it's a horizontal scaling by a factor of 2. Then the negative 5 is a D transformation like we had in the last problem, and so this time it's a shift down by 5. It's taking all of the output values and shifting them down 5 units. Now we need to apply this to the period, amplitude, and midline. So we know that the period is normally 2 pi, and we're basically dividing it by b. The reasoning behind this is not super intuitive, but hopefully you can just follow with me and believe it as we're going. So I'm going to take that b value too and plug it in for b. So I'm looking at the period being 2 pi over 2, which is just pi. So basically multiplying all of the inputs by 2 shrinks the period down to pi. Then my amplitude would be the A transformation, and I don't see any of those, so it's still just 1. It's unchanged from the original cosine amplitude. Then my midline is the D transformation, and we're shifting the whole graph down by 5, so my new midline is y equals negative 5. Okay, so let's draw a graph here. I'm going to give us some axes and remind us of all of our information. And then, similar to the last problem, I'm going to start with a graph of cosine. So cosine has a point at 0, 1, that's the first point, and then it sort of comes down on both sides coming away from it. I always make lots of hand motions when I'm doing this in person, so I can't really recreate that here, but as I mentioned before, it's probably helpful to just have a reference sine graph and a reference cosine graph until you get used to what they look like. Now, cosine usually has a period of 2 pi, and what we need to do here to get a period of pi is to condense it. So instead of repeating itself after 2 pi, we need it to start repeating itself after pi. So I'm thinking of taking this graph and sort of smushing it together. We're compressing it. I guess smush isn't a very technical word. So instead of having a point at 2 pi and 1, I now have a point at pi and 1. So I'm taking that point and compressing it. That means that the graph starts repeating itself after pi. So it does the whole down and then back up again in that little pi distance. And then I just repeat this over and over again to get my shape. So here we go. I've graphed it. I've just taken the points and sort of made them more compressed so that I'm getting that whole repetition in from 0 to pi. So from 0 to pi is 1 period, and then that repeats itself, and that's in comparison to what used to be from 0 to 2 pi. And this graph here is cosine of 2 theta, so that's our first transformation. My amplitude is 1, so I'm going to just leave that, but then for our last transformation, we need to get the midline down to y equals negative 5. So I'm just going to take this whole graph I've done and shift it down to negative 5. We see that the midline is at negative 5, and now we have cosine of 2 theta minus 5 as our final graph. Then I just like to check so I can see the period is pi since I start repeating myself after that distance. The amplitude is 1, and my midline is here at negative 5. So I've done this correctly. Okay, and then we're going to do one more example. We haven't seen a C transformation yet, so we're going to do one here. Let's say we have h of theta equals 3 times sine of pi over 2 times theta minus 1. Wow, that's not really very smooth to say, is it? But okay, this is our function. And I see here that we have 3, pi over 2, and minus 1. So each of those is going to be a transformation of some kind. First, on the outside, I see that we have the 3, that's an A transformation. So that's a vertical scaling by a factor of 3. Then inside the function, applying to the inputs, I have a horizontal scaling by a factor of pi over 2. And I have a shift right by 1. So that minus 1, when it's applied to the input, causes a shift right. Okay, so those are my 3 transformations. Now I just need to identify the period, amplitude, and midline. So for the period, we do 2 pi over b, We have a B transformation, so I'm going to need to do this. This is going to be something a little different, so I'm kind of excited to show you. So this B value has a pi in it, which is going to change things a little bit. So we do 2 pi divided by pi over 2. The pi over 2 flips. We're multiplying by the reciprocal. And so I have 2 pi times 2 over pi. Then my pi's will cancel, and I'm getting 2 times 2, which is 4. So my new period is 4. We've kind of gotten rid of the pi's altogether. All right, so then for the amplitude, this is affected by an A transformation. We do have one of those. We're scaling by a factor of 3. So our new amplitude is going to be 3. Then for the midline, that would be a D transformation. We don't have any of those, so our midline stays at y equals 0. And I'm just making a mental note that I still have that phase shift. I have that C transformation, so we'll need to make sure to include that when we draw our graph. Okay, so this is a transformation of sine, meaning I'm going to draw myself the basic sine graph and we'll start transforming it. So sine has a point at 0, 0, and then it goes positive to the right and negative to the left. And now I think the hardest thing to do is going to be to shift this period to be 4 rather than 2 pi. So I'm actually going to just relabel this whole graph in order to have like 1, 2, 3, and 4, rather than the radians involving pi getting in the way. So let me relabel our axes, and now I'm going to draw our new function that has a period of 4. So if I'm starting at 0, 0, I should do a full cycle of the graph and get back to where I started at 4 on the input. So my period is 4, and then I just repeat this little section over and over again. And this is the graph of sine of pi over 2 theta. So we've taken that period and shrunk it down to be 4. I actually think this is a pretty clean way to draw sine and cosine graphs because you just have like the whole numbers we're used to on the axes, and so it's kind of nice to have them this way. Then you should just remember that this function has a phase shift, and so I think we want to take care of that now. We could take care of the amplitude first if you want, but I kind of just like dealing with the phase shift first. So what's happening is we're taking all of the points on this graph and we're shifting them to the right by 1. So I'm just going to take some of these and draw them over by 1 to the right and connect the dots. All right, so here we go. We have sine of pi over 2 times theta minus 1. So shifting to the right by 1, and it's changing the period to be 4, using that pi over 2 factor. Okay, and then the last bit is just to change our amplitude. So the amplitude needs to be 3, and so I'm going to see all these points, the maximums and minimums, and just think about kind of pulling them up to 3 or down to -3. And once I've drawn these new points, I can connect them again, and we have our final graph, which is 3 sine of pi over 2 times theta minus 1. And there we go. We did it. That is our final transformation. Okay, so you can see here how these transformations can get increasingly complicated. I really think this is the sort of thing that you just need to do a lot of example problems with and get some good practice on. There's no way to teach you every possible thing that you might encounter. We just need to learn the building blocks so that you can apply them when you're given new examples. That's it for this one. Thanks so much for watching, and I will talk to you in the next one.